have a problem here under physics, right? And this problem is related to friction. So a block of mass 3 kg is placed on an inclined plane whose angle increased until the block is just about to slide down the plane. If the angle of inclination is 60 degrees, calculate the parallel force required to just move the block upward, move the block up the plane, right? So to solve this problem, we need to um, represent this information diagrammatically. So this is an inclined plane, right? This is an inclined plane whose angle of inclination is 60 degrees to the horizontal. Now this is the block. This is the block, right? This is a block, and this is the center of the block, of which the weight acts downward. Weight, which is equal to mass times gravity. And then from the center of the block to this direction is the normal reaction, which is equal to mg cos theta, right? And then one thing about an inclined plane, one thing about an object kept on an inclined plane is that there is always a force that tends to pull the object downward when you keep it on an inclined plane. So there's a force here trying to make this block to move downward, right? So that force is equal to, this force here is equal to mg sine theta, right? So there's a force here that tends to make this object, this block, to slide down. It's a constant force. It is always there as long as the block or object is kept on an inclined plane, right? Now, from the question, we are told to calculate the force that is needed, or the force that is required to make this object to move upward instead of it going downward due to this natural force. So what force can we apply to this object that will make it move upward? That is what this question is asking us. So actually, we want to make this object to move towards this direction, upward, right? Now, to calculate the force required to make it move upward, we need to first calculate the total forces acting downward, right? If we are able to calculate the total forces acting downward, we'll be able to now determine that. The value will now also represent the required force needed to push it upward, because total force acting downward is also equal to required force, right? Now, from the diagram here, it is very clear that there is only one force acting downward on the block, right? But then there's another force. There's another force acting downward here. So that force is called frictional force. Frictional force, right? So frictional force is also acting downward here. So we have another force here, which is called frictional force. So frictional force is equal to mu r, right? So as you can see, there are two forces acting downward on the block parallel to the plane. The first force is mg sine theta, which is a constant force that tends to make an object to slide down on an inclined plane. Then the second force is called frictional force, which is equal to mu r. Now, what is frictional force? Frictional force is an opposing force. It's a force that tends to oppose motion, right? So remember, motion means making a movement. That is the meaning of motion, right? So if motion is going forward, frictional force that tends to oppose motion will be going what? Backward. If motion is going upward, frictional force will be going downward. Frictional force is always in opposite direction to motion, right? Now, since our motion here is upward, so therefore frictional force will be acting what? Downward. Frictional force is always alternating. It depends on where motion, the direction of motion. If motion is going upward, frictional force will be going downward. If motion is going downward, frictional force will be going upward. That's just the understanding. So since we want this object to move upward, normally our frictional force should be acting what? Downward. So if you add the value of frictional force to the value of the normal force that tends to make this body to slide down, if you add the both of them together, we'll be getting our total force acting downward, and that value will also represent our RF, right? So to determine TFD, which is total force acting downward, we now know that there are two forces that are acting downward, and those forces are normal force, which is mg sine theta, plus frictional force, which is equal to mu r, right? Mu r. Now, r itself is equal to mg cos theta. So we are going to substitute r here for mg cos theta, right? So we have to determine the values of this quantity from the equation, right? So let's begin with theta. Theta itself is equal to, from the equation, theta is equal to 60 degree, right? And then m here, mass, is equal to 3. That's the mass of the block is equal to 3 kg. And then gravity is constant, which is 10 meter per second square approximately. And then theta is already here. Mu from the equation is not given. Mu is not given from the equation. So we can also determine the value of mu using that mu is equal to tan theta, right? And we know that tan theta here is already 60. So we have that mu will be equal to tan 60 degree, right? So from the calculator, the value of tan 60 is tan 60. That's 1 point. Mu is equal to 1.7320, right? So we are now going to substitute these values into this equation. So we have that TFD, which is total force acting downward, is equal to mg here from the values here. M is equal to 3 kg. So 3 times g, which is 10 meter per second. 3 times g sine theta. Value of theta is 60. So sine 60 plus mu. Value of mu is 1.7320. 1.7320 times m, which is 3, times g, which is 10, cos theta. Value of theta is 60, so cos 60, right? So let's compute this value. So 3 times 10 here will give us 30. So TFD will give us 3 times 10 is what? 30. 30 sine 60 plus 1.3 1.7320 multiplied by 3 multiplied by 3 times 10, which is 30, would give us 51.98 cos 60, right? So we have that 30 times 60 is 25.98, right? 25.98 plus 51.98 cos 60 should give us 51.98 cos 60 should give us 25.99, right? Now, if we add 25.98 plus 25.98 plus 25.99, 25.98 plus 25.99, that should be 51.97. 51.97. So therefore, total force acting downward is 51.97, and approximately total force acting downward should be equal to, if you approximate this, we'll be having 52 Newton, right? 52 Newton. Now, remember that total force acting downward is equal to required force. So if total force acting downward is 52 Newton, therefore required force that we are asked to calculate from the equation is also equal to 52 Newton. So 52 Newton is the force required to make or to push this block upward, right? And that's the final answer.